Right on top of this one, please, transformations. I think you'll like this. It really doesn't matter if you do or not. You have to do it, like most things. Liking and doing are two different things. You ready? Transformations. I don't believe this is the first time you've had transformations. Matter of fact, every day I wish there was some transformations in 7th grade, but it rarely ever happened. So there are, ladies. Oh, what is a transformation? Sorry. Anybody want to give me soap? Don't use the book definition because we don't. How often have you used the word alter in your life? Very rarely. By the way, it's a what? Is that a homophone? Alter and alter? Two different meanings for this. Is that a homophone or is that a homonym or is that a homograph? Caleb Fisher?
It's like moving shapes around.
Yeah. How a shape moves. And we have 3 different transformations that we talk about. The book has, I think, a couple of other ones there. We have what's called a reflection. We have a rotation. And we have a, I'll get it, no, a translation. What do these mean?
What do these mean?
Reflection is basically a mirror image. Or, if you will, in 7th grade jargon, maybe a flip. Okay. In other words, if you have, all right, you're going to force me actually to go to a, let's go there. Let's say you've got a triangle. Yeah, let's say you've got the triangle here. A mirror image of that. I really wish I knew how to use that cone. So here's your thing here. A mirror image of it would be like this. Oops. Oops. Oh, I still didn't quite get it, did I? Is that better?
Yeah.
Yes.
Nice. And usually when you have that mirror image, we talk about like its axis of reflection. I mean, this one is been reflected about whatever this point is here. That is your reflection. A rotation, in 7th grade jargon, we would call more of a spinning something. So if we had,
No, I had no.
so if it's a rotation, why didn't it go?
It's on the other one.
Oh, Caleb, what would I do imagine? A rotation simply means that it has been a little spinny thing. It has been turned. A spin, a turn. And a lot of times they will give you something about it was rotated 90 degrees about something. This would be its little point of rotation. And then last but not least, boys and girls, kids of all ages. Let's do this. Wait, how many of these do I have? Do I have another one? No. Stop. Huh? Is it over here?
Yeah.
That's something. What is a translation in the 7th grade world? That is simply a, when you slide it somewhere. Notice it doesn't change orientations. It's pointed straight up. What is that?
It's the wood chime. You don't know the stuff. It's really annoying. What the heck is the wood chime?
There is no
Why is there a
wood.
wood chime inside? Yeah, there's no wood.
So, let us look at this. Oh boy. Let me look at what they ask you first before we do something. What shall we look at, you ask?
What
shall we look at?
I don't know, let's look at Yeah, turn to page 174. Well, the one thing we're not done with the notes yet, but because we also actually have to put a fourth one in here because they do talk about it. They talk about a dilation. And what is a dilation, children?
I don't know, what is it?
Go to Dr. Brenner, if you go to Dr. Brenner or your eye doctor, quite often they dilate your eyes.
That's the one.
Oh, I don't like that.
Makes bigger,
I need more sunglasses.
Yeah. makes bigger, but it is proportionally. Proportionally. So if I had this thing again, if I was doing a dilation with my little triangles here, and this is a little tougher for me to do. If it was dilated, then it would, what is that?
Sounds like someone's boss right now.
Wait, why does this,
Probably something.
oh, I need to get this, can I move this one to the front? Yes, I can order it to the front, blah, blah, to you. And again, when you dilate something here, when you dilate it, it grows proportionately bigger. Everything grows at the same rate. It expands together. So hence the word here. Let's look at what they're going to ask from you. I know it's hard at the 7th grade level. I don't know if that's the one I really wanted though. Do I? No, turn to page 171. Let's back up a little bit. Do you see where it says example number 1?
Yes.
See, I don't know if I can draw that. I really should have copied that. The example says, describe the transformations that move triangle ABC to that new location. What do you notice about the A, B, and C of the second triangle? They have that little, what are those things called? They're not quotation marks. When it's one apostrophe, triple apostrophe.
I don't know.
In geometry / math, when you see that, like it has this, and then it has this. This is called A, this is called A, we call that little thing A prime. Almost like Amazon, but before Amazon was this stuff. And then if it had 3 of them, I think we call that A prime prime or A triple prime or something prime. And the reason you do that is because both of these points are kind of the same point, except it's been moved to a different location. So you want to keep it straight that this is also point A over there. So they are asking you in that example problem, you have A, B, C. Sorry, can I sketch it out? I don't want to waste most of your time, just all of it. That triangle is what? -2, 1, negative. What is that number? -2, 1. Is it -5, 1? Yeah, -5, 1. And what's the other point? Somebody help me out here.
Negative 2, 5.
5, 1, 2.
2, 5.
You sure it's 5?
Yeah.
Yes.
2.
So this was -2, 1. This was -5, 1. And that was -2, 5. Now this little triangle moved to the other side over there and became 2, 2, 6, 2, became 2, 2, became 1, 2, 3, 4, 5, 6, 2, and what was the other thing? Don't worry, I'll get it myself. You don't have to help me. I'll just stand out here. 6, 5. 1, 2, 3. And then in order for you to keep all that straight, these things are labeled. Here's what I mean. A, B, and C. A, B, C. And then it goes A prime, C prime, A prime, C prime, and E, whatever, that's just triple prime. I'm not sure I did that. So you have to be able to describe somebody how this shape ended up over here. Now, unfortunately, mine's a little goofy here, but it is not, it does slide, but you'll notice if it only slid, then A and A should both be at the same place. So A and B have somehow transformed into something else. So you have to figure out what would you do to this triangle to get it to end up over there. Anybody? Well, first of all, what would you have to do to it to get it to be orientated like that? Wow, they used all three. They did all sorts of things there. Well, the first thing they did, here, let me redraw this for you. In order for these things to switch around like they did, you are going to have to take this thing and reflect it. What is that noise?
I don't know who. It sounds low.
Which means this. Notice how B and C have kind of flipped places. I'm going to reflect this. Does that look like a good reflection to you?
Yes.
It works. I think it. Yeah.
So you've got the reflection, ladies and kids. Uh-oh. Oh, how did it change color?
When you press the
Stop, I know what I did. And then it slid over here. Well, let's keep our let's keep our point straight. When I reflected it, what happened here? Might have to not give you any assignment today because this is kind of a boring. This was letter C, right? This ended up being letter B, right? And this had to be letter A. So now I slid it over there, and then my last, in order to slide, which we call a translation, and now to actually get them to match up, what's going to have to happen?
Rotation.
You're going to have to take this thing and that doesn't look like a rotation, does it? Yeah, you try standing up here and doing this. Is that it yet?
No.
A little more. Wait, how does this work? Is it a flip?
No, it's just that my triangle isn't drawn right. This should actually match up. It's just that I didn't draw it quite right. Watch how I'll fix this. Watch this.
Ooh.
Shake it up, baby. Shake it up, baby.
Yeah, that's enough. Now look at page 174. I promise I'm just about done. If you've not done, I'm glad that whoever that lady was left before I got to all this. Oh, baby. Look at the top of the page here. It says rectangle PQRS is dilated with a scale factor of 3, forming the rectangle P prime, Q prime, R prime, S prime. Use this information, sketch rectangle P prime, Q prime, R prime, S prime, and label its length and its width. To which you would say, what do you suppose we should show on that? Well, if this was a problem from your book, this is what it would look like. What letter is this one? Practice letter E. What do you think you should do? Well, the first thing you would do is with the squares on your paper, you would sketch the original rectangle, which looks like this, and label its, what was its,
P, Q, R, S.
like here, P? P? Which one's P?
P is the
Just tell me when to stop.
top right.
P, Q here?
Yes.
R, S, and label its dimensions, which would be what?
Length is 6 centimeters and width is
6 and 4.
Yes.
Now, it says to make your new triangle dilated with a scale factor of 3, which means instead of this being 6, it's 3 times bigger, which makes it I know 6 times 3 is a tough one, yeah. 18. Now you don't have to necessarily, make it quite that big, but your new rectangle will be 3 times bigger, so it will look like this: 6, 12. This would be what? 18 and 12. And you would need to label this. This is P prime, Q prime, R prime, and S prime. That's kind of nice, isn't it? Very, very good. I'm not proud of that one.
So we have to put the prime.
Yes. And then it says the perimeter. Now here's an interesting thing. Everybody wait, focus. If you were bored all that time there, I want you to focus on this. Because believe it or not, we talked about this in 8th grade and you still don't get it. But I have confidence that you will, because most of you are, I'm going to do this a little nicer, not happy with my lines. Alright, listen to this. Here we go, ready? Wake up if for nothing else for this. Letter F says, the perimeter of the dilated image is how many times the perimeter of the small image? Well, that's logical, isn't it? We made it 3 times bigger, yes?
Yes.
So let's do it. The perimeter of this is, looks like 20, right? Small perimeter equals 20, right?
Yes.
Big perimeter, that's 30, and another 30 is,
60.
wow, nothing revelation about that, is there? So how many times bigger is it?
3.
Okay. All hands on deck. Chase, you're looking up here. Lauren, you need to look up here because this is very, very important. Stop. Right now. Letter G, children. Big dramatic pause here because all of you are thinking that letter G, the answer, because it asks you the area of the bigger one is how many times the area of the smaller one. You right now are saying, well, it has to be 3 times bigger. And I'm going to tell you, you are incorrect. Let's do it, and then you'll see. Letter G, the small area is 6 times 4, anybody?
4.
Now, if that was, whatever it is, units squared. If that was true, the area of the big one should be 72, right? 3 times 24. Well, if I take 18 times 12, children, I get 36, and 18, I get 216 units squared. Does that seem to be 3 times bigger? In actuality, how many times bigger is it?
A lot.
Like 8.
It is 9 times bigger.
I said 8.
Now, just because I can, and I know you don't want any homework, humor me on this.
So
Humor me on this. Let's put this into 7th grade terms. If you go to the pizza place, and let's say, is there a place that, Lauren, what was the square pizza place?
Francesca.
Okay, you're at Francesca's?
Yes.
Spell that.
Yeah.
All right, Lauren, you are at Francesca's, and he offers you you can buy a 10-inch by 10-inch pizza for $10. Or you can buy a 20-inch by 20-inch pizza for $30. Which one is your better deal, Lauren? 30-inch, wait, no, I said 20-inch.
Yeah.
20-inch by 20-inch pizza
30.
for $30. Would you not be better off to buy 3 of these and get a 30 of whatever by 30 pizza?
Yes. Yeah. Because
you get more
pizza for the same amount. $30. You would because that one you only get 300 pieces. Wait.
You would still
That
get
one
the
is
same.
$3.
You get more pizza there for the same price as that one, but you have less
$30.
pizza there.
Madison disagrees with you. She says this one's obviously a better deal.
30.
That 20 is 20 times 20 is 400 and 10 times 10 is 100.
Alright, if you're talking about area, Madison, take a look here.
Oh, area.
Well, no, I said which one's the better deal, it doesn't matter. When you're talking about pizzas, you're talking about area, are you not? Do you buy your pizza by its perimeter? Do you go into the store and say, can you give me a 40-inch perimeter pizza, or do you say, whatever? Alright, the area of this one is 100, is it not? The area of this one is 400. This one is 4 times bigger. So the price for it to be equal, the price would have to be 4 times more. Which, if you think about it, okay, look at this. This is a 10 by 10, right? If I were to drag this pizza over here, it would take up this much of it. It's a 10 by 10. It's half of each one of those. This is how much this pizza would be in this bigger pizza. And how many of those could you get out of it? 4 of them. 1, 2, 3, 4. And here is the reason that is. It's not, doesn't make common sense. But what you have to remember is when you double a side, I have not only doubled one side, making it twice as big, but I also doubled the other side, which actually makes it 4 times. You have doubled and doubled again. When you double both dimensions, you double it twice. Does that make any sense to you?
Kind of.
When you double both dimensions, you are doubling 2 numbers, not just 1.
But then how is it still 4
How is what still 4?
times? Oh, because there's 4.
Emma?
So with the one before that, it would be 3 times 3.
Yeah, which means that the other one was 9 times bigger because we didn't double each side, we tripled each side. We tripled this side to make it 18, and you tripled this side to make it 12. And 3 times 3 means you made it 9 times bigger. It's the same thing as when we say if you have 1 yard squared equals how many feet squared? Everybody always says, well, it's 3 feet squared. No, if you look at what a yard squared is, a yard is 3 feet by 3 feet. You actually tripled both sides of it. I mean, went from a 1 to a 3, went from a 1 to a 3, which is tripling both sides. It's actually 9 feet squared. Or a square foot is how many square inches? Don't say 12, because obviously that wouldn't make any sense, because it's 12 by 12, it's 144. Where are we at here, kids?
No, I have a question.
Maybe, wait, let me see if I can find it here for you. Madison's question will throw us off. Is it about math?
Yeah.
What, Madison?
So for like letter G, and then you have just done